Hello. Today we're going to walk through how you can use Explore Analytics to take a set of time series data and project it into the future to make a prediction. We're going to start with an example set of data, incidents created by week. It's extremely easy for us to project this information into the future so my organization can know what to expect. When I'm looking at this timeline, first I'm going to enable the trend. You'll notice that in the blue header bar I have a few options of different kinds of trend. You'll notice that we have a few trend options. A line trend, which shows a linear regression line. The average, which just shows the average of all of the points of data as a horizontal line. The median, which does the same but with the median instead of the average. A moving average, which averages at each point of data over the last few periods. And exponential smoothing, which does the same but with some formulas attached to smooth the line. We'll talk about those a little bit more. But let's start with the line trend. Now you'll see that when I select any kind of trend, I also now have the option for a forecast, which I can now turn on. That's going to enable the projection of that trend into the future. Once I've turned on that forecast, I can use config to modify that projection. For a line trend forecast, there's only one option to populate: how many periods you want to forecast for. Now, a period is the set of time that we're grouping by on this chart. So because this is a trend of incidents by week, the forecast period is in weeks. So 36 means 36 weeks. If I'd prefer to project for 1 year, I would put in 52 weeks. And now that line is going to project from the end of my data set into the future for 1 year. Now you'll notice that with a linear regression, the line forecast is just taking a straight line of the trend and projecting it straight into the future. As we work through these trends and forecasts, it's important to understand how these trends are being calculated and what that means about the level of accuracy into the future. With our set of data, the line starts at near zero and slopes up and to the right, so that within a year it's somewhere around the 100 mark. When you look at that data visually, do we think that's an accurate projection of the future? In this case, because there was a sharp rise in incidence between 2014 and 2015, when my organization grew rapidly, that's creating a very big effect on the trend, whereas after that point, it seems like the data is mostly horizontal, large peaks notwithstanding. A straight line projection may in some cases be appropriate, but in this case it might be misleading. Let's try some of the other trends and see what it tells us. With the average, or with the median, we see the opposite effect. Rather than sloping up and to the right, it's keeping that consistent horizontal line. The average is lower than the median because of that longer stretch of time where we had a low number of incidents. So according to the median, we would expect something between 50 and 70 in terms of the projection, which is a lot less than that 100 that we saw when we used the linear projection. The average or the median assumes that we'll have something similar to what we have right now. That's not always a bad assumption to make, but it's important to understand that that's an assumption, and it's a different assumption than the line trend. Let's try something a little bit more advanced to see what happens. Let's try the moving average. The moving average bases trend and projection based on recent history. You'll see that it stays a lot closer to the line over time, and then when it reaches the end of the data set, it projects to wherever that moving average was when it reaches the end of the data. The reason that we call it a moving average is because it's taking into account changes in the data as they happen. It's calculated by taking each point of data and averaging it against the last few periods. You'll see that for a moving average, we now have an option for periods that refers to the periods of the moving average. So right now, it's looking at 36 periods. Again, periods are measured in this chart in weeks because that's what it's grouped by. If I wanted to have the moving average do just the last 12 weeks, I can change that and click OK. You'll see that by having less periods, the line tracks the data set even more closely. That's because when you take more data in consideration by having more periods, it tends to smooth the data more. Whereas if you take less data into consideration by specifying less periods, it tends to track the ups and downs more closely. This means that you'll want to use more periods when you want to smooth out a very noisy set of data, so that you're not, for instance, following things like this huge spike we have around April. And you'll want to use less periods if you want to be sensitive to spikes or valleys as they happen. Moving averages are a pretty good way to map closer to your data, but you can get even more fine-tuned control with exponential smoothing. You'll notice that when I switched it to exponential, initially it's very similar to a moving average. But I have the ability to configure this even more by going to that forecast config again. You'll notice that we have more options than we had before when we were looking at the linear, average, or moving trends. The first option is still forecast periods. As we said before, that's the amount of time we're projecting into the future. But now we have the ability to control what type of exponential smoothing we're going to use. Do we want to use a simple, a trend, or a seasonal? We'll walk through each of these right now so you can understand the differences. We started right now with a simple exponential smoothing, and you can see that that's where it maps the data and then projects a straight line towards the end. For simple, the only option to control is what you call the alpha, which is data smoothing. If you increase the alpha, it gives more weight to the data that's towards the end of the data set. So if I raise this up and click apply, you'll notice that the moving trend is much more close to the data points, and where it ends is very close to where the data ended up. Again, that's because the alpha is telling us to treat recent data as more important than older data in that period of the moving forecast. To see the opposite, if I drop this extremely low and click apply, it doesn't follow the data nearly as closely as it was before. It's still following it to some degree. You see that it maps quite closely to 0, and then it eventually gets close to that higher number after the spike in 2015, but it's not following the various peaks and valleys nearly as closely. So for the moment, let's set it to 0.15, which seems like a fairly reasonable set of alpha. Now let's try the trend. You'll notice that when I selected trend, we got another option here, which is the beta. And let me click apply so you can see what that changes. Now, you'll see that we're still following the data similar to the simple exponential, but now we're ending with an upward trend, similar to the linear regression that we had when we used the line trend. The reason is because we're now taking into account another variable, which is the beta. The beta talks about the trend, or the change in the data, at the end of the data. So a high beta gives a lot of weight to how the data was trending. You'll notice that towards the end of my data, the data is going up. So because I have a high beta, now the exponential smoothing assumes that this uptick is going to extend into the future. So it grows very rapidly, and you'll see that now we're projecting more than 100 incidents off in the future. If I put this as a very low beta, it's not giving a lot of weight to that at all. It's almost a horizontal line. And in fact, if you set the beta to 0, you actually have the same as if you were using a simple exponential smoothing. Simple exponential smoothing is a trend where the beta is 0. For the moment, I'm going to just set that to 0.15 so that you can see kind of a mix of the alpha and beta. For seasonality, we're going to take into account another variable that we haven't really taken into account before, which is the seasonality of the data. Seasonality refers to what time of year the data sets are, or time of month or time of week, depending on the periods. So, for example, assume that these incidents are being opened up in my organization. All of the trends we've looked at until this point assumes that we'll have roughly the same amount of incidents come in, regardless of whether it's Christmas or the end of summer or the middle of April. But in some organizations, we might have a period of time where we see consistently higher or lower numbers of incidents. Winter breaks tend to be low, beginning of fall tends to be high, etc., etc. So the seasonality is going to help us map our data. You'll notice that when I turned on the seasonality, we had a spike that happens right at the beginning of the year here, and it happens again at the beginning of the next year in our data. If I was to reduce the number of periods to 26 weeks, you'll see that that actually happens now twice a year. The seasonality measures how often that season repeats, and the season periods is what you measure that in. And again, that's going to be measured in whatever you're grouping by, in this case weeks. So as I increase the number of periods, the data doesn't repeat as much. If I decrease it, it repeats more. The gamma is also related to that seasonality. The gamma tells us how much we should weight recent seasons versus earlier seasons. So what that means in effect is the most recent December more or less representative than earlier Decembers? So if I increase this, you'll see that in this case we're not seeing a lot, because towards the end of my data we don't have a lot of large spikes. And if I decrease this, you'll see more spikes in the data because we had bigger spikes earlier in the year. In fact, if I had to guess, the big spike that's happening at the beginning of the year is likely a reflection of this big spike that we had at the beginning of 2015. So if I want to ignore that more in the data, I might raise that up. You'll see that seasonality forecasting is the only one where the line in the future looks a little bit like the kind of data we'd expect, with peaks and valleys. That doesn't necessarily mean that it's more accurate, it just means that it's doing a little bit more fine-tuned forecasting. You'll notice that as I've been making these changes, I make the changes and I click apply so I can preview what's being created. And you'll see that just by making a few changes, it's very easy for me to drastically alter what that projection line is. The reason is because all of these controls that we're changing are modifying different assumptions. You want to make sure that you're clear on what those assumptions are so that you understand why the projection model is forecasting this. All of these options around projection and forecasting are telling you something based on the future using information gathered from the past. But you can't actually tell the future. The chart has no idea if you're going to make a major change or if your organization will change in a large way between now and that future it's projecting. So it can only make informed predictions based on these controls you've seen. There's no one answer on whether you want to have a high alpha or a low alpha, or whether you want a high beta or a low gamma. It's important to know what the assumptions that go into these are. I recommend that you explore your data, you examine the results, you work your way towards predictions you can explain and understand, with assumptions that you're tracking. Once you've done that, you'll be able to really use the power of this information, discarding outliers like this huge spike from a major outage in April and smoothing the noise of the line, to let you see what's going on underneath the data and what might happen if current assumptions hold true. Good luck. If you'd like more information, I recommend that you go to our wiki for more product documentation or find more video tutorials here at this channel.